Hello, science fans. My name is Sunny B. Collio, studying computer science and engineering. Let's talk about something that's all around us, something you're using right now to read this: computer science. Now, what is it, really? It's not just about playing video games or sending emails, though those are part of it. At its core, computer science is the study of how to solve problems using computers. It's about being a detective, a builder, and an artist all at once. Think of it like this. You have a problem, say. You need to sort a giant pile of 1,000,000 different colored marbles. Would you sort them one by one? Would you get friends to help? Computer science is the art of coming up with the perfect set of instructions, a plan to get that job done as fast as possible. To understand where we are, we have to look at where we've been. Think way back to ancient mathematicians who created step-by-step processes to solve math problems. These were the first algorithms. In the 1800s, Ada Lovelace and Charles Babbage envisioned the analytical engine, a mechanical computer that was never fully built. She wrote what's considered the first computer program. She imagined a machine that could do more than just crunch numbers. She saw the future. During World War II, brilliant minds like Alan Turing created machines to crack secret codes. Machines like the ENIAC were enormous. They filled entire rooms, used thousands of vacuum tubes, and were programmed by physically plugging and unplugging wires. Then came the transistor in the late 1940s. This tiny device changed everything. It made computers smaller, faster, more powerful. All right, let's get physical. Computer hardware is all the parts of a computer system that you can actually touch. Think of it like your body. You have a brain, heart, bones, muscles. They all have specific jobs to do. A computer is no different. The most important piece of hardware, the computer's brain, the central processing unit, or CPU. It's a tiny chip that does all the heavy lifting. It performs calculations and executes commands at incredible speeds. It's the boss that tells all the other parts what to do. Next up, memory. There are two main kinds. First, random access memory, or RAM. RAM is the computer's short-term memory. It's workspace. When you open a program or a file, it gets loaded into RAM so the CPU can access it quickly. The second kind, storage, long-term memory, like a filing cabinet or a library. You save your files, photos, games, and programs permanently. If hardware is the body of a computer, then software is its soul. Software is the set of instructions, programs, data that tells the hardware what to do. You can't touch it, but you see its effects everywhere. It's the ghost in the machine. Think of the OS like Windows, macOS, Android as the manager of the entire computer. It's the first program that loads when you turn the computer on, and its job is to manage all the hardware and software resources. The operating system provides the foundation upon which all other software is built, creating a stable environment where applications can run smoothly. So we know software tells the hardware what to do. But how do we create software? The answer is programming. Programming, or coding, is the process of writing instructions for a computer in a language that it can understand. It's kind of like writing a very, very specific recipe for a robot chef. Computers only understand binary, zeros and ones. Programming languages act as a bridge, using words and symbols that are easier for humans to read and write. We've mentioned this word a few times, but what exactly is an algorithm? Don't let the fancy name scare you. An algorithm is simply a step-by-step set of instructions for completing a task or solving a problem. That's it. You use algorithms all the time without even realizing it. A recipe for baking cookies is an algorithm. The route your GPS gives you is an algorithm. Let's go back to our marble sorting problem. One algorithm might be, pick up a marble. If it's red, put it in the red bucket. If it's blue, put it in the blue bucket. Repeat until no marbles are left. Think about a search engine. When you type something, it sifts through billions of web pages to find the most relevant ones in a fraction of a second. This is possible because it uses an incredibly clever and efficient search algorithm. Let's talk about data. Data is just a collection of facts like numbers, words, measurements, observations. Your name is data. Your age is data. Think about a library. A library with no system would be useless, but libraries have a system. They use catalogs, organize books by genre and author. In the digital world, we use something similar called a database. A database is an organized collection of data, structured to be easily accessed, managed, and updated. You might think computer science only happens in high-tech labs, but it's woven into the very fabric of your daily life. Let's start with your morning. The alarm clock on your phone? That's a simple program. The smart thermostat that adjusts your home's temperature? That's an embedded computer running algorithms. Think about your commute. If you drive, your car is packed with computers. Engine control unit, anti-lock braking system, GPS navigation. If you take public transit, scheduling systems, ticket machines, and real-time tracking apps all rely on computer science. In medicine, medical imaging helps doctors diagnose diseases. DNA analysis accelerates discoveries. In finance, systems power stock markets and protect online banking. In art and music, digital tools enable new expression. In agriculture, smart tractors and field sensors help farmers optimize yields. The world of computer science is always moving, always changing. One of the hottest topics right now is artificial intelligence and machine learning. Instead of programming explicit instructions, machine learning allows a computer to learn from data. You can show a computer thousands of pictures of cats, and it will learn to recognize a cat on its own. Another huge trend is cybersecurity. As more of our lives move online, protecting that information becomes incredibly important. We're seeing a massive shift towards cloud computing. The cloud is a global network of powerful servers that you can access over the internet, making powerful computing resources accessible to everyone. The Internet of Things is rapidly expanding. This is connecting everyday objects to the internet. Your watch, your refrigerator, your doorbell, and even your shoes. One area poised for massive breakthrough is quantum computing. Unlike regular computers that use bits, quantum computers use qubits that can be both 0 and 1 at the same time. We will see AI become more integrated into our lives, moving from a tool we use to a partner we collaborate with. The future of AI is about humans and AI working together. The way we interact with computers will change dramatically. Instead of keyboards and screens, we may move towards voice commands and direct brain-computer interfaces. This is why understanding computer science is more important than ever. It's not just a field for specialists, it's the literacy of the 21st century. Whether you want to build the next great app, solve climate change, explore space, or create amazing art, computer science provides the tools to turn your vision into reality. The future is unwritten, and the people who understand this language will be the ones to write it. The possibilities are, quite literally, endless.